Okay, so as you can see, we have some definitions because we're talking about a new chapter. Chapter 5 is going to be, should be called The World of Polynomials. But since it's a math book and not something clever, it's just called Polynomials and Polynomial Functions. I like World of Polynomials. So please take a few moments and copy this stuff down. Let's go over these just real quick. When we talk about a polynomial, we'll talk about, first of all, a polynomial that only has one term. We use the prefix mono. You may have seen the prefix mono before. I always think of mononucleosis.
I know.
The first thing that comes to my mind.
That's not good.
But mono must have to do with the cells. But also, anybody who plays Monopoly, the short dude with the top hat,
They're trying to be the only one.
he's always wearing
Monocle.
a monocle. It's one lens. You know, it's usually on a string. Monocle, mono, one.
How do you keep that on?
You kind of close your eye around it. When we talk about a polynomial which can be a monomial or the sum of monomials.
Is it, well, poly, the Latin root is poly, which means many.
That's right, thank you. Poly means many, like a polygon.
I love
Which
that.
reminds me, what did the pirate say when he lost his parrot?
What?
Polygon.
Oh.
Poly means...
What was the joke?
What?
What was the joke?
What did the pirate say when he lost his parrot? Polygon.
Oh!
I was just like,
That's a Gasparilla joke. Not her Gasparilla. So poly, as Laura was, as Jillian was so kind to point out, poly means many. So polynomial is going to be a many-term monomial. When we talk about polynomials, one of the things we're going to talk about is its degree. When we talk about the degree of a monomial or a polynomial, we're talking about the exponent. So whatever the value of the exponent is, that's the degree. So 3x to the 4th power, we would say is a 4th degree monomial. There's a special name for it. We'll talk about that a little bit later. Same thing with the degree, except when we're talking about a polynomial, the degree of the polynomial refers to only the largest exponent. So here in this 4-term polynomial, even though I have x to the 5th, x to the 4th, and x to the 1st power, if I'm asked to give it what's its degree, I'm only going to look at the one that comes first, the one to the highest, I should say. In a second, you'll see why I said the one that comes first. But for now, just the highest degree. And then polynomial function, I wouldn't worry about that too much, but it's self-explanatory. It's a polynomial function. A polynomial with the variable x defines a polynomial function of x. The degree of the polynomial function is the same as the degree of the polynomial. Basically, this is a polynomial. If I said f of x equals this, it would be a polynomial function. That's the difference. So polynomial is just the expression. Polynomial function is it's going to equal f of x or p of x or q of x or whatever. Okay, is everybody not done copying? Okay, and the last thing we're going to, the last definition, not the last definition for today, but the last definition in this section, standard form. When we talk about standard form, think back to when we just did quadratic equations and we put something in standard form of a quadratic equation. Standard form was ax squared plus bx plus c. Here, and you notice we have x squared, then we have x, and then we have some number by itself. Well, standard form means going from the highest exponent to no exponent. From the highest to the lowest, and then bringing up the rear is the constant. Does anybody know why we call it the constant?
It doesn't change.
It doesn't change. It is constant. All these other values in my example there, they're going to change depending on the value of x, but not by negative 2. The negative 2 is going to stay negative 2 no matter what x equals. So it doesn't change. We call it a constant. The other piece of information you should be aware of is we do have special names for certain terms. I mean, certain degrees, I should say. We have a linear term. That means it's an exponent of 1. And if you think about, if I were to graph this, 5x plus 3, what would I get? What would I get if I graphed that? What would my graph look like?
Wait, what was the question?
The question was, what would the graph of 5x plus 3 look like? What would it be?
Well, the y-intercept would be 3.
Uh-huh.
And then it would go up 5 over 1.
And what would it look like when I finished connecting the dots?
Positive. A straight line.
It would be a line. All lines are straight, otherwise they're not lines. Otherwise they're curves. But yes, it would be a line. So remember, so we don't have an exponent, it's linear. An exponent of 2 means quadratic. We just spent an entire chapter talking about quadratics. If I have something to the power of 3, we call that cubic. And I'll talk about in a few minutes, we actually have special names for an exponent of 4 and an exponent of 5. Beyond that, we would just say, like if I had this, if I had x to the 6th power, we would say that that is the simply 6th degree. So any 6 and higher, you just say the name. 6th, 7th, 8th, whatever. You're welcome. Okay, now, let's talk about classifying polynomials. Just as you and I both have names, or we all have names, so too do polynomials have names. So we're going to learn how to name the polynomial. The first thing you want to do if you are given an example is take that polynomial and put it into standard form. Put it from highest exponent down to the constant, which goes at the end. So this trinomial, so named because it has 3 terms, like tricycle, has 3 wheels, triangle has 3 sides, trinomial has 3 terms. So first thing we do is we're going to put this trinomial into standard form. And you'll see when we do the next problem why it's important to first put something in standard form. As you can see, it's easier to classify because the one we want to focus on is the one that goes first. So if you don't have it in the proper order, when you go to name it, you're not going to name it correctly. And so we look to get the degree, we look at the highest numbered exponent, which is 2. To get the number of terms, we simply count 1, 2, 3. Remember, a term is some value separated from another term by a plus or a minus sign. So 3 times x, 3x is 1 term. It's multiplication. But when we separate 3x from the 5 and the 9x squared by 2 plus signs, we end up with 3 terms. 1, 2, 3. So don't just count the number of things. Don't say, okay, 1, 2, 3, 4, 5. It says 5 terms because it's got a 9, an x, a 3, an x, and a 5. 3x is a term, 9x squared is a term. The first name of the polynomial is the degree. And again, we look at the highest numbered degree. That's 2. So that we call that a quadratic. Remember, something to the second power is a quadratic. And then it's got 3 terms, so we call it a trinomial. When it comes to the second name, we don't have anything past 3. Anything past 3 would just be a polynomial of however number of terms. So you'll see in the next one, it's going to be a polynomial of some number of terms. The first name refers to the degree, the highest numbered exponent. The second name is the number of terms. Okay, so what I'd like you to do is I'd like you to take a minute, take a look at this one, see if you can figure out what its name is. It's a good question. The question was asked, why did I rewrite it over here? Is there anybody who can tell us? Why did I rewrite it from this to this? Why? Putting it in standard form, Lucas, from highest exponent down to the constant. Okay? You're always going to want to do that first because that's how you're going to classify it, by looking at that first exponent.